In this video, we're going to work with this second order linear differential equation using the method of variation of parameters to find its general solution given the functions y1 and y2 as the linearly independent solutions to the corresponding homogeneous equation. Now, if this happens to be unknown, the values of y1 and y2, then you just have to equate the original initial value problem, the left side expression of the original IVP, and equate that to 0 instead of the function to the right side of the equation. Now, since this is already known, then we just have to find the general solution of this IVP. Now, we have y of t is equal to yc plus yb. This is the format of our general solution. Now, yc is our complementary function and our yp is our particular solution. Now, yc is already c1 y1 plus c2 y2, and we just substitute the values of y1 and y2, then we then have our complementary function. Now, this is easier than the particular solution, and the particular solution is given by y1 u1 plus y2 u2, where your y1 and y2 are given and your u1 is equal to the integral of w sub 1 over w, and integrate that over dt, and your u sub 2 is equal to the integral of w sub 2 over w, and integrate that with respect to dt. Now, w means the Wronskian, and the Wronskian is given by y1, y2. In your first row, you just put the independent linear solution, and in the second row, you just put the derivatives of these functions. Now, your w sub 1 is equal to, you just change the first column. Instead of y1 and y1 prime, you just change that to 0 and f of t. The same with the w sub 2. Instead of changing the first column, you change the second column. And then let's find our f of t. Our f of t will be used in finding our w sub 1 and our w sub 2. Now, our f of t is given by, since this is our IVP and this is the right side expression of our equation, then we just divide this expression here by the literal coefficient of the y double prime, so that our y double prime term won't have any literal coefficient. We'll divide this equation by t, or we just simply multiply 1 over t. That's why our f of t is 8t e to the negative 5t. Now, this is our Wronskian, y1, y2. Let's put our y1 here and our y2 here, and let's take the derivatives of these functions. Below the y1 is the y1 prime. The derivative of 5t minus 1 with respect to t is 5. And the derivative of y sub 2 is negative 5 e to the negative 5t. Now, taking the determinant, we just simply multiply these minus the product of these. Now, negative 5 times 5t minus 1 times e to the negative 5t minus the product of this one, 5 times e to the negative 5t is this one. Now, that's simplifying. We factor out the e to the negative 5t, and the inside expression has negative 25t plus 5 minus 5 in it is equal to, cancel this, 5 minus 5 because this is 0, Our Wronskian W is negative 25t e to the negative 5t. Now our Wronskian sub 1 is equal to, we just change the first column. Our first row, first column, change that to 0. And our first column, second row, I mean, sec like first column, second row, change that to f of t. Our f of t is this one. That's why we have that here. And finding the determinant, 0 times negative 5 e to the negative 5t is just 0 minus 8t e to the negative 5t times e to the negative 5t is negative 8t e to the negative 10t. Now our Wronskian sub 2, we change the second column instead of the first column. We change the first row, second column to 0, and our second row, second column to f of t. Now, finding its determinant, you just simply multiply the y sub 1, our y sub 1 is 5t minus 1, to our f of t, 8t e to the negative 5t minus 5 times 0. Since this is 0, then we just leave that and written. Now, this is our Wronskian sub 2. And now, to find our u sub 1, then we integrate w sub 1 over w with respect to dt, and our u sub 2 is equal to the integral of w2 over w dt. Our w sub 1 is this, and our w is this. We cancel this, t over t, and negative over negative is just positive. That's why our constant is factored out, or this 8 over 25 integral of e to the negative 5t. Negative 5t is the exponent here because negative 10t minus negative 5t is just negative 5t. Now, integral of this one is this, and we have our u sub 1 is equal to negative 8 over 125 e to the negative 5t. Our u sub 2 is equal to our w sub 2. This is our w sub 2 we got from the previous solution over a Wronskian negative 25t e to the negative 5t. Now factoring out the negative 8 over 25 outside the integral. Now what remains is 5t minus 1 dt. Now integrating this, 5t, the integral of 5t is simply 5 over 2 t squared, and the integral of negative 1 is negative t. Now, distributing, we have 8 over 2. Negative 8 over 2 is negative 4. 5 over 25 is just 5. That's why we have negative 4 over 5t squared here. And then, for the second term, is distribute this to here. Negative 8 times negative t is just positive 80, and 25 here as our denominator. Now this is our u sub 2. Now we can plug that in our particular solution, y sub 1 u sub 1 plus y sub 2 u sub 2. Our y sub 1 is given, and our u sub 1 is this. We just substitute that, and our y sub 2 is given, and u sub 2 we got it from here. Then you just substitute that. Now, since our general solution is the sum of the complementary function plus the particular solution, we just substitute our complementary function and our particular solution. Now, this is now our final answer for our general solution of the initial value problem. And that's all.